Now we've got a heap of these little handles here. So these are an aluminium handle and they have this knurling around the outside there. So what we have to do is drill and ream a 10mm hole through it, but not all the way through, probably 3/4 of the way through. So the issue with this one is, well, how are we going to hold it? Because the little knob on there, we can't take that out. That doesn't screw in, I'm assuming, and it's sort of looking like it's pressed in. So we can't take that out, so we're stuck with this thing hanging out. And we can't hold it by the knurl by any material harder than the material it's made out of. We don't want to squash the knurl. So what I was thinking, I've got this piece of plastic here. It's like an acetal type of material. I'm not exactly 100% sure of the grade, what the stuff is. It's quite a hard stuff. So what we'll do is we'll machine a pocket for the hand wheel can sit in, and we'll just drill a hole through so the handle can drop in. Then we can mount this. Oh, we'll put a slit in it. We'll put a slit in it. Okay, so we're 2 inches there. So what we'll do now is we'll pop it in the mill and we'll get a hole through for the clearance hole for the handle here, which will all have to sit in that way. So we've got our part clamped in now, and we'll just use the indicator to set it up on directly under the quill. And we have a bit of a stop here. So the work holding part, the little jig, locates in the same place every time if it happens to move while we change a part. So our basic work holding, or our basic stop, is just the old down and dirty method, just built up out of strap clamps, and that's my normal method of doing it. It's simple, so that's why I do it. So what we'll do is we'll get a drill bit set up and we'll drill a hole just under 10mm so we can put a 10mm reamer through. Now it's already got a dimple in it there, so we don't need to start off using a starter drill or anything like that, so we can just plough straight in. Okay, so we have our work holding fixture now all finished. The hole in for the handle. And we also added a saw cut through because there is a little bit of variance in diameters on these hand wheels. So he just pushes in up against our hard stop. Drop the part in. Give it a good nip up. Bit of a tap down. And we're in location for drilling. So we have our stops all set. So what we must ensure is our drill bit is bottomed out up inside the chuck. We'll get our hole through. So it is going a blind hole, so in with our chucking reamer. Once again, make sure it's bottomed out right up inside the drill chuck. So that's our Bridgeport depth stop just here. Now because we're reaming to a different depth when we're drilling, we put that piece of tool steel there. Now that brings us our reamed hole a couple of millimetres shy of the drilled hole, which you never want to bottom out a reamer because it will tend to make your hole a bit oversized. Quick deburr. That's the part done. So it goes over this shaft. Beautiful fit. Pop fit. Oops. So I'll continue with the rest of these. The only other operation in these, we do have to drill and tap for a grub screw on the side there. Okay, so the procedure we're going to use for drilling and tapping the M6 cross hole. So we have our stop just with our strap clamps, and we're also going to register off the end of the vise, the fixed jaw. So we just push up in between those two surfaces, keeping our little handle in the 12 o'clock position. Quick nip on the vise. Centre drill and our tapping size drill. And our tap. Being only a small bit of thread, M6 and aluminium, we're just going to wind it by hand. That's it, she's through. That's it, that's that part done. We've got these 33mm 6061 aluminium bars to do now. So basically all we've got to do with these is machine them to length and a chamfer or radius on the end, and then there's a big 18mm slot in the middle and a hole gets drilled and tapped up the end. So it comes out, yeah, there's a big slot, chamfer or radius, either or, and a M12 hole gets tapped up the end there. So we'll get them all machined to length first, and then we'll get on with the other features. Using a carbide end mill for aluminium, we're just machining these bars to length. So this is the first cut initially, then we'll flip them around, put them against the backstop and take another cut to bring them to final length. It's just I find it's quicker and easier to do it this way than to do them in the lathe. Let's go to WD. Now our next operation with these soft jaws, we have to bore the jaws to 33mm diameter to hold these aluminium bars. And the reason why we're using soft jaws to hold it is we don't want any jaw marks put in the material. So the method we use to do that, right at the back of the jaws there's a flat. As I've said before, I've still got to make a boring ring for this set of jaws, but in the interim there's a little flat behind the jaws at the back, and I'm using a nut off my clamping kit, which is the diameter seems to work out pretty good. So we just slip that in, wiggle it around till it's looking good. Nip her up. Turn the lathe on and see how it's looking. I don't think that's too bad. So we'll get a boring bar set up, and now we can bore this through to 33mm diameter. So we have our jaws bored out to size to suit the bar, and when you do this you have to make sure you give the chuck a really good clean out and a good deburring of the jaws. I'll just run you through a couple of basics of some of the methods we used to do. It's called block turning. So you might have a multiple of parts like that to do in your lathe, and your lathe isn't geared up for any sort of production work. So using the soft jaws, you'd bore your soft jaws through to a shoulder, same diameter as the bar stock you're using. All your parts go in, you'd set a tool up, preferably to face and chamfer in one operation. Part gets flipped around and same thing happens again. So then you've got all your parts to an exact length, faced and deburred. So then when it comes to the other operation, part gets slipped back in, you set a tool up. Say on something like this, I'd probably do that in this small lathe. A bigger lathe I'll do it in one cut, a smaller lathe you want to do it in two cuts. So you do two roughing passes. So you finish, say, for instance, 20-30 thou above your finished diameter. Now those roughing passes, if you're taking it in two cuts, it's critical. Both cuts you are coming into the same number on your cross slide dial all the time. So you've taken your roughing cuts, parts are all done, they go back in for a finish pass. So you set your tool, you adjust, any adjustments are done now for the finished diameter, and you can run them all through. Now, the reason it was critical on your roughing passes to finish on the same dial graduation on your cross slide as it will affect your tool pressure for your final pass. So if they're not the same on your roughing cuts, your finishing cut, you won't be able to hold consistency. It's a battle to do it, and you find you're making adjustments all the time and you should not be. So yeah, you just lock your cross slide and run them all through on your finished pass and done. Oh, excuse me. So that's a very easy method, block turning on a manual lathe with no production attachments on your machine to do short run multiple parts. And of course, to get exact lengths that are repeatable, you'd use you'd fit a carriage stop to your lathe, so you're coming to the exact length every time, and your parts will be guaranteed to be the same. Okay, that's all the corner radiuses taken care of on both ends of these parts. So what we have to do now is drill and tap an M12 hole up the ends, one end only. Just using the tool as a visual aid, just so the parts are approximately sticking out the chuck at the same time. So we go through first with our largest spotting drill and we take it right to the maximum. Our 12mm tapping drill. Then we slip our tapping chuck in. So what we'll do is we tap the hole up to that orange line there. Gives us our required depth. Plenty of WD. Oh, before we do that, anti-bozo. This is deeper than what we're tapping. Just a quick check to make sure I haven't missed a number while drilling the hole. Okay, now unfortunately with this lathe I've lost my reverse, so I've got to hand crank that tap out. Now that's tapped in the hole 1.5 inches deep. Yeah, something's happened electrically, that's why I've lost reverse. I think it's just in the switch. And there she is, that's that part done. So I'll run through the rest of them and get all the holes done. Now we're just chopping out our slot prior to going in with a milling cutter. It's quite quick to remove it with a drill first. Now our slot finish size is 18mm and we've just got a 16mm 5/8 drill bit here. It's not actually my preferred option to do it this style with a drill. I would sooner do it with a carbide 5/8 or 16mm end mill for aluminium, but I don't have one, so this is working fine. Just have to, as long as you're very steady with your feeding down in with the interlapping holes, you'll be fine. Okay, that's all our holes pre-drilled. So now to finish the slot off, we'll pop in a 12mm long series end mill. Okay, I'll give you a quick overview of our plan for doing the slot. So basically it's this square slot we're doing in here. Now we put our parts back in, and I'm just using an end mill and eyeballing it, looking at that way, just to get our part orientated, and that's plenty close enough for what we have to do here. As long as I can see the 5/8 end mill looking that way, we're in line. So we'll pop the end mill out, and we'll come back to our starting position. So our length is determined by the hard stops I've already set on the table travel, and we have our dial set at 0 for the width, so we are in the middle of the slot, and what we do is we offset 3 millimeters either side. Well, it's actually 3.1 millimeters either side. That keeps us in our tolerance range of 18.2 to just under 18.2 wide. So what we do is we bring our table back. Now we use the quill and push the end mill through, then we push the table in 1 millimeter. We do this all in 1 millimeter steps until we're at 0.4 millimeters below half the distance of our finished width. So we'll keep plunging down with the end mill, and that will chop that corner out. Then we run across up to this corner, we pull back up again with the end mill, and then we do small increments again, going down with the quill to chop out the corner, and the same with the other two corners. If we don't cut vertically with the end mill on the corners, because we're cutting across the whole, well, most of the face of the end mill, you'll get a lot of chatter and it just doesn't work out. So once we've run around once, then we take it to final dimension, and we can leave the cutter down and just do a quick run all the way around. So I won't be able to explain that as I'm going, but you'll see what we're doing. So hopefully this little explanation will tie in with with what you'll see next. As we see here, we have our table stops set for our table travel. Okay, for our cross travel, we're relying on the dial on the knee, so we can then move the table across to get to the full width of our slot. But when we're at the other end, we'll be relying on the indicator readings, so that takes care of any backlash issues, as the indicator will give the absolute position of the table at all times. So we'll set you up and we'll run through a slot. Okay, that's the roughing pass completed, so we'll do the final step over to take the slot to 18.15 to 18.2 millimetres. I'll just shut the camera off for a sec because I need a full charge of air on the compressor to keep blowing the chips out. Otherwise the chips will get jammed and I don't want any double cutting going on. Okay, the compressor's all charged up. So it's the dog next door by the sound of it. Okay. Okay, so we'll check the width of our slot. So we're just using a parallel, adjustable parallel, that would be. So if I can try and get a measurement without sticking my big fat hand in the way. Just nip it up. Come around this side. So we're looking for between 18.1 to 18.2 millimetres, ideally 18.15. So if we look at that, you probably can't see that. But that's exactly what we have. $18.15. So, yeah, using the dial indicator to track your cross feed on your table is the only way to overcome your backlash and get accurate results. Okay, we're up to the last operation on our part now. So what we have to do is pop a cross hole drill and ream for 6mm. Has to be perpendicular to our slot. So what we're going to do, we reference off the parallel, push it up against our hard stop just there. We're in location, bit of thumb pressure. Nip the vise up. out with a parallel. And centre drill. And through with our 6mm reamer. That's that part complete. Okay, this is our array of parts, all finished and assembled up, and this is the end result. What it is, it's a fine height blade adjuster for a Robland X31 saw, wood saw. So it gives the cabinet makers and guys that use these saws a very accurate blade height adjustment on what the original saw had. So this has a quick release nut for fast travel, and then of course the handle there they get their fine feed from. And this handle goes onto the original saw's blade height handle, where it just had a handheld handle, and this bolts up to the frame of the handle, and then it has this other part here. So these will go over there, and then that will line up on the degree indicator for the blade tilt. So, another job done and dusted. Okay, well let's wind this one up now. So that's our small production run of parts done, and as you've seen by the previous photo, yes, it's for a fine height control adjuster for a Robland X31 woodworking saw, so they can get some accurate adjustment on the height of the blade for whatever they're doing. So what we're going to do next is move on to our tool and cutter grinder. So we need to get that up and running, as I have quite a few cutters that need sharpening, and we're going to go through a basic, well, once we've got the tooling made up that we need to operate the grinder, we'll start going through some basic procedures on how you actually set your tools up to grind, how to grind the relief angles through offsetting the centre height, etc. So we'll make that quite a basic exercise, that one, so it's easy for myself to grasp and the rest of you guys. It's as there's a lot in tool and cutter grinding, it's like a trade on its own. So, but we will touch on that. So anyway, take care. Thanks for sticking around, and we'll see you in an upcoming video. And that was the other thing too. The machining videos may slow down a tad leading up to the new year and into the new year, as the production on the new shop, I need to really pull my finger out and get this new shop up and running. So that's all more fabrication type work, but very time consuming. So we'll see you later.